In 2015, the new Campus Derendorf was opened, uniting the different locations and providing excellent facilities. The library and the campus IT are in a historical building within modern architecture. The canteen and administration are in central proximity. The Faculty of Social Sciences and Cultural Studies, as well as the Faculty of Business Studies, belong to the largest entities. The upper floors of the lecture halls and auditorium are the home of the Faculty of Media, including the studio cluster. The building for the Faculty of Design and the Faculty of Architecture is still under construction. The Faculty of Electrical and Information Technology and the Faculty of Mechanical and Process Engineering have a large number of laboratories and do contract research for industry. Virtual Studio, as part of the studio cluster, innovates the studio technology with synergy of virtual reality and broadcasting. It is a pleasure to welcome you to our report on automatic camera and switcher control for live broadcast using scene analysis and expert system. My name is Andrea Gerhardt and I'm going to guide you through this demonstration. While I'm talking to you, the semi-automatic system is running as test and demonstration of its capabilities. A markerless actor tracking system provides our own system with tracking information like position and rotation. With that information, appropriate camera perspective can be calculated and applied. The robotic camera determines its position based on the scene analysis. For example, the robotic camera is currently in the track camera mode, so it follows me and keeps me in focus and determines the field of view. Now the system cuts back and I'm recorded by the jib arm again. In contrast to the robotic camera, the jib arm is manually operated by a cameraman. The switch was done automatically based on my body orientation. And again, through tracking of my body orientation, the robotic camera automatically took over. I can even walk on a big circle in front of the camera and stay in focus. Setting the robotic camera focus manually during my current motion would be challenging, but it's quite easy with our automatic approach. That is neat. Now we welcome Jens Serda, professor at the Faculty of Media. He will explain the system in more detail to us.
Also welcome from my side here in the virtual studio in Düsseldorf. We have a live graphical model of our situation in front of us, which will help you to understand more easily what is currently happening. More challenging for our system is handling a scene with two persons like our situation now. Who should be in focus? Some additional information besides the position is necessary. For audio recording we use lavalier microphones. The voice level from the microphone is used to determine who is talking.
That amazes me. So that means that the camera always focuses on the person who is talking.
No, that would be boring. In the long run, the viewer also needs to know that someone is listening and nodding his head. So after a certain period of time, which is adjustable in our expert system, the focus will switch to the listener, obeying the cinematographic rule that the new camera position must not cross the line between the actors.
Okay, that sounds interesting. So how do you handle those rules? Is it a piece of software?
If we would code that into a program, the system would not be flexible enough. It is necessary to adjust the rules depending on theme, format. So we implemented an expert system using a state machine with corresponding low-level camera modules and rules, and which determine the switch of the cameras depending on sensory input like actors' positions and microphone levels.
I still do not understand how the system works. So how does actor tracking work?
We have 18 cameras here. They belong to the Open Stage Organic Motion system. And they take the silhouette from us, construct a volume for each person, and based on proportions and color information, that information is used to place a skeleton into that volume, and that is sent to the graphic engine for further processing.
Okay, so my question is, how do you include the manual camera into all this?
The cameraman has a mobile device with an app which shows the state of the system and gives requests for certain shot types. He tells when he has a suitable image by pressing a button depending on his judgment.
Okay, and is the idea of automatic camera control new?
No, but the combination of Virtual Studio and camera control and tracking is relatively new and creates a new application area. It is very interesting to put those cinematographic expertise into a live system.
What is the most challenging part in your development?
The hybrid nature of the system, both manual and automatic cameras are in one environment and have to support each other to create a compelling production. The robotic camera has a mass and limited degrees of freedom. It cannot leave the dolly, for example, so that the number of camera positions is limited. When the robot gets a new command for different positions, it will take a while until that position is reached. The expert system has to take those delays into account while choosing the next camera shot. Also, the system works under live conditions, and processing all data has to be done in real time.
Great. And how do you deal with the problem that the robot requires some time to reach a desired position?
That's a good question. We try to predict the changes within the situation. Each rule has a priority associated, and we take into account those probabilities, and we adjust those by hand or using a learning phase at the beginning.
And what kind of different camera modules do you have?
You already experienced the track and pan module yourself. With one person, the camera robotic moves and takes into account the orientation and the positions. Besides these camera modules, we have one person who has the Apex external and internal camera modules for two persons, like now. And the Apex camera module gives a total equal view of two actors, which is often used for introductional shots. The external and internal modules show one actor in more detail. The external module shots of a person who is talking, mostly over the shoulder, and the internal, on the other hand, gives a close-up to the face.
Okay, so the system looks already completed. Do you see any possible developments?
Our prototype is just a beginning. We need to implement more rules. For example, the field of view was rather fixed, and it did not adapt to the situation. We have to do more tests, especially with more people in front of the camera. Also, we would like to have an automatic ongoing learning phase in the background, improving the predictions.
We just got a glimpse of the future in automatic camera control developments for broadcasting applications. It is fascinating to see how everything works together for bringing the best picture into the audience. This system relies heavily on sensory input, like a markerless actor tracking, camera tracking, and microphones for analyzing the scene. It performs different actions, for example, setting different camera perspectives while keeping focus, and perform cuts between the cameras, respectively. Thanks belong to all students who worked on this production while being enrolled in the Master of Media Informatics. Thanks for joining our report, and we would like to welcome you on our new campus in Derendorf. Goodbye.
Goodbye.